Hello everyone, and welcome to the first session of the Blender 102 class, where we will be exploring the process of modeling out a character. Now, before we actually get into today's class, there are a few things, some announcement if you will, that I need to get out of the way. First one is that in today's class, my role here today, is to introduce you to several of the modeling tools, not just those associated with BMesh, but basically a big overview of many of the tools that you will need and those that you can use while creating your own characters and objects inside of Blender. So you can think of today's class kind of like a modeling primer. Second, I am assuming that you are coming to this class equipped with at least the knowledge that we covered in the Blender 101 class. If you didn't attend that class, that's okay. You'll probably be just fine in today's class, most likely. But if you get through today's class and you feel like you're a little bit left behind, you feel like you're struggling or having a hard time with things, it would be a good idea for you to go and check out the Blender 101 class videos. As a member sponsor, you have access to all of those and you can watch them whenever you like, which is a really good idea in your case. Now, we also have some other Blender videos that you can dive into if you so desire. We have the Blender Fundamentals videos. We have a couple of different projects where I think we model out some spaceships or something. What did we do? Didn't we do like a Battlestar Galactica ship at one point? And I feel like there was something else, but honestly, all the videos that I've done kind of blur together. Yeah, there was the banana dude at one point as well. So there are a lot of various resources here on 3D Buzz to help you get up to speed if you feel like I am shooting over your head today. However, I'll be honest, I'm pretty sure that won't happen. Really, again, today's job is to serve as a bit of a Polygon primer to get you up to speed with modeling with polygons, to introduce you to BMesh and how it works, give you some thoughts on topology, stuff that I think everybody who's modeling needs to know kind of in advance, some basic terms, terminology, and thoughts. Now, a couple of other things. How is this class going to work? Hopefully, you have all taken at least one of the other classes here, but I'm seeing some new names, so I'm going to get through this pretty quick. Obviously, you've got the hard part down in that you have signed into the webinar. You can hear my voice. That's good. You're going to need to do that, of course, at the scheduled times. This class does run twice a week. We'll be doing it on Tuesdays at 3 p.m., and on Thursdays at 7 p.m. Now, all those times are based on Central Time, CDT. That's my time zone. So if you need to know what time it is in Tennessee, please punch that into World Time Server or something and make sure that you have that adjusted for your own time zone as necessary. Now, please note that the classes that run during the same week will contain the same content. So the class that runs on Thursday will essentially be the same as today's class. It's important to be aware of that so that you don't show up to Thursday's class hoping to find something new. I will say this, no two classes are really ever alike. Most often I'll end up explaining something maybe slightly differently, or I'll cover one thing that maybe wasn't quite mentioned, because there are so many different factors when you're working with people. I do also want to mention this. I am having an interesting time with an audio feature right now. So in today's class, system audio, meaning audio coming in from the outside world, which includes you guys and Gavin, may not be being recorded as well as it should be. I am going to do my very best to get that solved by the Thursday class, but if you hear me repeating pretty much anything that is said to me that sounds important, then that's why. It's just to make sure that that does make it into the video. On that note, this class is being recorded, so if at any point you're following along and you feel the need or the desire to leave for some reason, you can do that and watch the video later at any time. Okay, so there's the basics of how this class works, but there are a couple of other things I do want people to know about. First off, many of you are here because you know that this class offers a certificate. I can't spell, so if you guys want to, just can, yeah, it's gonna be that kind of day. So, a certificate of completion. This certificate is really just from 3D Buzz. Please don't think that you can just show this to a random person on the street and they'll, give you a medal or a job or something. It's just something that we're giving you that is, just so that you can have and know that you completed this class. But how do you get this? There are two factors. There is attendance, and there is homework. For attendance, you need to have attended at least 50% of the classes. Now, that means you need to attend 50% of all of the Tuesday classes or all of the Thursday classes. You don't have to, and you can switch and swap between the two. Basically, you need to attend 3 of the different weeks that are going on, and if you miss 3 or more than 3 classes, then your attendance won't be up to snuff, and you won't be able to get your certificate of completion. Be aware of that. Also, you will have to turn in all of the homework. Now, I'm going to talk here in just a few minutes about how homework is assigned and how it is presented, how you guys are going to be turning that in. Make sure that you completely understand that, because if you are just getting into these classes for the very first time, some people get confused by this. It's very basic, but there's one thing you do need to be aware of. You need a Dropbox account. It is free, so don't worry about that, but please make sure you do go over to Dropbox and sign up. Now, for this class, you will be submitting all of your homework, and it will be checked by Mr. Gavin Whitlock, who is with me right now. Say hi to everyone, Gav.
Hello.
Yeah, see, he's there. And I think when he shouts that loud, we can pick him up on the video, but again, I'll be worried about that and fixing that a little bit later today. So, when you guys are given assignments, all you're really going to do is put them into a shared folder that we'll have set up with your Dropbox account so that we have access to those. Now, when you turn in an assignment, it will either be completed, you will have done everything you're supposed to do. If you mess something up or your work is incomplete or for any reason we feel that you need to try again, you will be contacted and you'll be asked to resubmit your assignment. So please stay on top of that sort of thing, because if we ask you to resubmit and you don't, then you don't get credit for that assignment. Plain and simple.
And if if you're planning on handing it in, if something happens, you can't hand it in, and it's a reasonable enough excuse, send me a PM before the deadline saying, sorry, it's going to be late. Don't send me a PM after the deadline saying, hey, I didn't get it marked because I didn't submit it, because I will say, well, you should have sent me a PM before the deadline.
Right. And what Gavin is getting at there, for those who may or may not have heard that, is if you need an extension for some reason, make sure you PM Gavin. He is FatGav on the website, FATGAV, and make sure that you contact him prior to the deadline, not after the deadline, explaining the situation, and we're more than happy to work with you. Okay, last thing I do want to mention, and this probably won't be an issue for Thursday's class, but it's certainly one here. I am getting over a tremendously terrible chest cold, so if I'm talking and I suddenly go silent, it's only because I've hit the mute button so I can try to hack up one of my lungs real quick, and I don't really want to do that in everybody's ear. So if you would just bear with me on that today, then I, of course, would be greatly appreciative. All right. So, getting into today's class, just real quick, how many people do I have? If you can just tell me inside of BuzzNet, I would appreciate it. How many people do I have in here who did not attend the 101 class? Okay, there's a few people who didn't, which is cool, and of course you're very much welcome here. Hopefully you're at least passingly familiar with using Blender. Now, I'm getting a couple of questions in the question system over in the webinar. Please, if you have questions to ask, do so in the webinar. And one of these that came in was, sorry, don't have BuzzNet access. Yes, you do. You need to open up a web browser and point it over to buzznet.3dbuzz.com. If you are listening to a webinar, if you are in this webinar at all, you also need to be signed in to buzznet.3dbuzz.com. Because I will be kicking people out who are not logged into both systems. I need you over there. It's critical.
And that is buzznet.3dbuzz.com, not www.
Yeah, there's no www. It's just buzznet.3dbuzz.com. You can do that. And for those of you who need an explanation, for those of you who ask why, the answer is because I say so. That's why. Because the people who ask why are severely punished. That's why. All right. So it looks like some people are coming back in, which is good. We're getting the numbers starting to kind of even out. Please just remember, if you are listening to this webinar, you also need to be logged into buzznet.3dbuzz.com. Okay, so today, what are we going to be looking at today? We are going to take a look at the basics, the essentials, if you will, for polygon modeling in Blender. Now, if you were a part of the 101 class, we got to play a little bit with polygon modeling. We did some really, really basic stuff, but really at the end of the day, if you think about it, most of what we did was just bring in some very basic geometry, mostly primitives, some spheres and whatnot. We did a few extrusions because we were feeling particularly special, and that was about it. Everything else we did was extremely basic, and we're going to be going way beyond that today. But in order to do that, there are some things that you need to know, some concepts, some terms, and some tools that I want everybody to be aware of before we jump in. So today's goal, I'm going to go over some terms, go over some of the tools. I'm going to talk about B-mesh, what it means to you. We're going to talk about good geometry. We're going to talk about bad geometry. And then I am going to model a very, very simple object, and I haven't even really decided what it is. It will be modeled entirely on the fly, just kind of for the fun of it. I'm going to give you guys a very basic modeling assignment of your very own, and then I'm going to turn you loose. Now, I also want to throw this out there, and this is just for those of you who have been following along with some of our classes in the past. I'm endeavoring, mostly for your benefit, and also so that we can keep these classes rolling a bit more smoothly, to get away from the classes that reach way out into the stratosphere of times. So I'm going to be trying to keep this down toward the 2-hour mark. If we run a bit over, we run a bit over, and that's just the nature of the beast. But I am going to try to keep this very, very focused. So, those of you who were not in the 101 class, and I guess those of you who are, let's do a really, really quick review of a few things. So here's Blender. And again, just because I'm now on the video, I just want to mention to everybody that I am using 2.63.0. If for some reason another version of Blender is released during this course, I will not be upgrading. I do not upgrade in the middle of a class unless it's something that is absolutely mission critical. If for some reason that we have to because the tool that we want to use is broken or causes Blender to explode, and they fix that, then we will upgrade. But if it's just something minor, I try not to do that because I've had a lot of problems with that in the past. Okay, a couple of questions. Is Gav also first to PM about Blender technical difficulties, problems, or you? You can actually PM us both. Did you?
For technical things, it should be starting a thread before.
Yeah. Yeah, generally it's a better idea to start a thread. You will probably get faster responses that way. We can't always be standing right next to our PM boxes with some of the things that we're doing. So that'll probably be your fastest way to get a response, please. Now, someone just asked, can anyone tell me the link for the Blender 102 Dropbox, please? That's not how this is going to be handled at all. There is no one constant Dropbox. We'll talk about that here in just a little bit. Will the fact that I basically finished the F14 project and Max Fundamentals help here? No, not really. I mean, you know what a polygon is, and that's good. Any change to look at B-Surface's modeling plugin? Any chance to look at the B-Surface? No, I'm not going to be looking at plugins right now. We're going to go straightforward with just Blender as it stands. Though we may end up having an extra class after this where we take a look at specific plugins and so forth. Okay, so real quickly. When you are working in Blender, of course, all of you at this point know that you can hit the Tab key and take a look at the components. And if you hit Control-Tab, you have access to the 3 primary components of any polygonal object, being vertices, edges, and faces. Hopefully, at this stage, regardless of what training videos you have or have not followed, you are quite used to hitting Control-Tab and then hitting either V or E or F to jump between your 3 different component types. That is something you will need to be really on top of as we work, because I am not going to be calling out very basic things like that. So make sure that you're very comfortable with jumping between our 3 components. Now, talking about components kind of begs that I bring up this word. Now, is there anybody out there who does not know what this word is? You can tell me over inside of BuzzNet. But I know what, does anybody not know what topology really is? Yeah, pretty much. It is this.
A better response than I expected.
Yeah, the study of tops. Well, in terms of modeling, you can think of topology as the arrangement of polygonal components across a surface. In what order are the vertices all arranged? How are the edges lined up? That's how you can think of topology. Now, please, I do want to mention to people, please try to refrain from just chatting over in the questions panel, Gavin. So let's see here. Now, again, topology. I just want you to think of this as the arrangement. I don't even want to say flow right now, because flow comes with all kinds of additional stuff. And to kind of help show that off, I'm going to bring a model in. So let me open something up real quick. And this is a guy that may be familiar to some of you out there. I mean, maybe some of you recognize this character. Though this is his debut inside of Blender, just for everybody's information. Now let's take a look at the topology of this character. And again, that is the arrangement of his polygon components. So his edges, his vertices. Take a look at how his edges flow around the shape of his belly to help kind of define that shape. Notice how there is a higher concentration of edges at key points that have to bend and flex. And that's going to be done specifically for the purposes of animation, so that he can have a lot clearer opportunity to deform in those areas. If you don't have enough deformation, enough geometry in an area that is bending, your deformations are going to look problematic. You're going to look like you're folding a soda straw, and you'll have nasty creases. But also take a look at how the edges flow down the length of the geometry. How they kind of outline the shape, but are more or less very straight as they go down the surface. Now this is a very simple topology, and topology does become more complex in certain areas, not only just in this model, but in general. I will bring this up. Here's a nice little, something that I'm going to have to talk about a little bit later, but I want to point it out a little early. Notice how around the mouth in particular, we have loops of geometry. Edge loops. You see, like around the lips, we can start like right here, we can go all the way around the mouth. You see it goes underneath the lips and all the way back around. You'll see this around the eyes as well, and the purpose of these loops is to give you a nice flow of deformation. Human faces deform in a way that is very similar to having these edges flow around each one of these openings around the face. And we'll talk about how to create those as we get deeper into character modeling. Okay, so let's jump back over to Photoshop for just a moment. So topology, again, it's the arrangement of polygon components. There is good topology and there is bad topology. You probably won't be able to differentiate too much of the difference between the two when you first get started, but here are some guidelines that will kind of work as rules of thumb. Good topology flows cleanly along a surface. Basically, what you want to be able to do as a good modeler is take a look at your model and take a look at the edges, not only the longitudinal but the latitudinal lines as well, running in both directions, and you want to see them flowing along the shape in a way that makes sense. You don't want to see an edge maybe going down the leg and suddenly zigzagging sharply off to the left or to the right. You want to see things flow very, very nicely. If you picture like maybe your own arm, like you can hold your own arm out in front of you. You picture drawing the topology, the actual polygon grid that would formulate your arm. You'd probably start by running big, long lines all the way down your arm, or you would start by drawing loops maybe around your wrist and working all the way up. In both cases, that's an intuitive way to think about topology. Your edges should form lines that flow nicely along the shape. Spider-Man's a really good example. If you take a look at the lines that form across Spider-Man's mask and across at least the chest part and the red areas of his costume, depending on, I guess, which version of Spider-Man you're looking at, then you get this... Yeah, you get this nice flowing grid that moves across the surface where you can follow those lines and they trace across the entire shape of the three-dimensional character. All right, now back over in Photoshop. Bad topology. Moves in random directions. Edges do not cleanly define a shape. And that's a real problem. It can be okay, and I'm going to say this with you have to understand, there is no one hardcore set of rules in 3D. Every time you come up with a rule in 3D, you'll come up with an edge case where you can break it. But I will mention this. Good topology and bad topology are much more important to consider in terms of deforming objects. So when you have an object like a character that needs to bend and flex and move, then your topology is going to be absolutely critical, because your topology will help determine how your object will flex, how it's going to deform as it is animated. Where bad topology can make your deformations look unbelievable, look unrealistic, and that's a problem. However, if you are creating an object that is completely rigid, that is never going to bend and never going to flex, then the rules of topology are suddenly not as important. Because in those cases, you don't have to worry about deformation. You just need the object to look good. So it's one of those things where you have to kind of keep in mind what it is you're modeling for. I've created models that are sent out via maybe SolidWorks or to a 3D printer, where really all you need is a bunch of triangles. And the final result, the topological flow, is nowhere near as critical as just making sure that everything is nicely shaped and solidified. So it depends on what you're up to. I'm sorry?
I tend to find you can get away with topology in hard surfaces that you can't in anything organic shaped.
This is true. Sometimes when you are working with various topological forms, especially organics, it is nice to be able to keep your topology very clean if you need to do organic surfaces that are still nice and flowable and readable. But yeah, with harder surfaces, it's less to worry about. Okay, a couple other things I do want to point out real quick. It's going to be that kind of day. Quads and triangles. When making good topology, your end result should essentially always be quads and triangles. And if it's a character, more often than not, especially if you're going to be smoothing it out, if you're going to be using subdivision surfaces, then you want it to be more quads than anything else. Now, when I say subdivision surfaces, what am I really talking about? Well, specifically in terms of Blender, I'm talking about grabbing your character and dropping on a subdivision surface modifier, and maybe kicking up the viewport factor just a little bit so that he's nice and smooth. If you know you're going to be using subdivision surfaces to smooth out a character, you want to keep things in quads as much as possible, with maybe the occasional triangle only where you absolutely have to have one. So don't get carried away with triangles. Now, at the same time, if you know that your final output is going to be perhaps to a game engine, then triangles become more important, and you should be thinking about how your triangles are laid out. So there's just two things that you do need to be aware of while you're working. Now, at this point, we've talked about several things already. We've talked about topological flow, quads, and tris. We've talked a little bit about edge loops and subdivision surfaces. Now, I understand that a lot of this stuff will not really get a chance to sink in, and you won't really get a chance to fully understand it until you do a lot of modeling. My goal is to just introduce you to these concepts and talk about them, answer any questions about them that you may have. I also want to mention this. One of the big reasons that I like doing this sort of chalkboard style lecture where I jot things down is that generally, if I'm writing something down, it's because it's important enough for me to take a note of, and I do highly encourage those of you who are into this to take notes on your own. I think all of these classes will work much more smoothly for all of you, even if you don't think they will, if you have a small notebook and pen and paper and you are writing stuff down while I am talking. I think you'll find that if you take some notes, you can often go back over the notes and recreate an entire classroom lecture worth of stuff. Or even if not, you can take your notes, review back over the video, and you'll find stuff sinking in much more cleanly. So I am going to highly encourage that everybody takes notes. But if you don't, that's fine. I can't really, I can't force you to. I can only stress that I think it's a really, really good idea. Okay. Now, this brings us to a couple of other things. We've talked about quads, we've talked about tris. Does everybody know what a quad and a tri is when I just tell them? Hopefully you do. A quad is a four-sided polygon. And a triangle, as you may have guessed, is a three-sided polygon. Now, internally, every single quad is actually two triangles. You do need to kind of be aware of that, because when you output even a quadrangulated model out to a game engine, more often than not what happens is it gets triangulated so that every quad is split up into two triangles. Definitely something to be aware of. Alright, and now that you can no longer see what I'm drawing, there we go. This brings us to a different type of geometry, because prior to the most recent releases of Blender, this was all you had to work with if you wanted to create a polygon model. All you could create were quads and triangles, which was nice in that you were basically always restricted into having a very nice piece of geometry when you got done. It was also restrictive in the sense of what you could and couldn't smoothly and cleanly make. Now, I don't want to speak badly of Blender in any way, because in the end, you could model anything that you wanted to inside of Blender, given enough time and patience. However, as of Blender 2.6, was it 2, I think? They officially put B-Mesh into the Blender trunk, basically into the actual program itself, so that we could all play with it. And B-Mesh allows you to create ngons. It looks kind of like ngong, doesn't it? That's not true at all. N for never leave them in a completed model. Now, what is an n-gon? An n-gon is a polygon with n number of sides. So it could be, technically I guess it could be a quad, or it could be a triangle, but generally you're going to think of an n-gon as something that has... I didn't even count however many sides it is. 1, 2, 3, 4, 5, 6, 7, 8. This would be a nonagon. This would have 9 sides to it. Prior to the advent of B-Mesh, you could not create a piece of geometry like this inside of Blender. It simply would not happen. It wasn't allowed. Now, however, you can create this if you want to. Now, I just got a question that came in. If it's a bad idea to leave them, then why include them? Well, I think the big easiest way to answer that, the most meaningful way to answer that question, is how you think about n-gons. I like to think of n-gons as a means to an end. Basically, if I'm modeling, and let me jump back over to Blender real quick. Say I'm doing some stuff, and I'm going to turn off this modifier. And for whatever the reason, I need to work on this area right here. I don't like the way the topology flows. I don't like what's going on with it. And I need to, for whatever reason, clear this out. Well, because I now have n-gons, I can say, all right, give me you, 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 and you. I can hit X, and now I have a new feature called dissolve. Watch what this does. I've just wiped out all internal geometry in here. So now this has a 1, 2, 3, 4, 5, 6, 7, 8-sided polygon. That was completely impossible before. But now we can switch over to vertices, and I can be like, well, let's move this up here. And I want to split this in a very special way now. So I'm going to hit the knife tool, and we'll go from here to here. And then maybe get the knife tool again, and maybe just split from here to here to here. And then one more knife tool split that goes from here to here. Maybe that's closer to what I actually wanted. Now notice, I'm finished now, and I'm not saying you ever want to do this, okay? This is just an academic kind of case in point. Notice that I'm now finished, and I have everything back to quads and triangles. But in the process, during the construction period, I was able to just wipe out everything that was in my way and create brand new geometry, something that was impossible before, because now I'm able to produce these n-gons. Now, again, I do want to stress, leaving them in your model, it may not be the end of the world. It's not a good idea. It generally leads to bad geometry. Any polygon with more than 4 sides could probably be considered to be bad geometry. Does that mean it's going to crash Blender? No. Does it mean that your entire scene is just crap and you should throw it all away? No. It just means that for certain applications, you may have problems if you try to output an n-gon piece of geometry. For instance, if you try to send that out to a game engine, depending on how the triangulation algorithm works, you may have serious issues there. Some rendering engines will only render quads and triangles, and so you have problems there. And then if you're smoothing, you can have all kinds of problems. Go ahead, Gav.
Yeah, I was kind of good. And which will leave you with odd triangles left over, which can then cause problems with smoothing. So
Right, so what Gav is getting at is that when you have an n-gon, basically you've lost a lot of control over what's happening to the inside of the shape, and I can actually prove that here. So if I go back over to faces, and if I would grab all of these guys, and once again, we just hit X and dissolve them. So now they're just a single object. Watch what happens if I turn smoothing back on, and we get out of here for just a moment. Take a look at the two different sides of the geometry. Here I've got a relatively smooth flow from the sternum out to underneath the pectoral. Over here, and it may be difficult to see unless I rotate just right, we're getting this really weird sort of pinching taking place. Because we have no geometry within that n-gon to really control what's going on there. There's nothing actually telling Blender how this surface, how this piece of geometry is supposed to be subdivided. So generally speaking, you won't want to leave it this way. You'll want to make sure that whatever n-gons you have do get split back up into the appropriate quads and triangles. I want you to think of n-gons as a means to an end. They're just a construction tool. They're a way that you can take a piece of geometry and say, all right, I don't like the way this topology is flowing, or I need to make an adjustment to it. And rather than be forced to always work in quads and triangles, which means you're going to have to add a lot of extra edge loops and then maybe collapse some of them down, you can just say, you know what, I'm going to nuke everything in here. I'm going to carve out my own topology that looks good, makes sense, and does what I need it to do. And I can do that because I can start off by cleaning the slate and starting off with just an n-gon.
there's another huge situation that this makes possible, and it's kind of my initial one-word answer for why would you need B-mesh if you're not going to leave them, which is chamfering. You can't do it without the B-mesh.
Well, that's true. Now, well, that's true. What Gavin just said is that now with B-mesh, you do have the ability to chamfer or bevel, if you've heard it called that before. And we're going to talk about those tools as well. Now, you could manually do it back in the day. It was just a pain, but it could be done. What I'm actually talking about in this case are geometric impossibilities, because previously you were unable to just take all of the internal geometry within a selection, as we have here, and just say, you know what, remove all of the edges and vertices and let me carve in some new detail based on what I think it should be. So that's again, I just kind of want to point out, in terms of what I'm trying to teach you here, the idea of an n-gon is that really it's a means to an end. It's something that, generally speaking, you should not be leaving in your finalized geometry. It's just while you're working on something, it is a lot easier in many cases to dissolve it out to an n-gon, get rid of all of its internal geometry, and then maybe use something like the knife tool to put in your own customized flow of polygons, rather than have to be forced to put in a lot of edge loops or things that you would have had to do prior to the implementation of bmesh. So are there any other questions about that? Does that make sense to everyone? Okay, good. So folks are following along with that pretty well. Okay, so the next thing that I want to do is talk a little bit about not just topology, but just kind of make a quick note about geometry in general, and what is, when you hear people say, you know, the geometry here is good or the geometry here is bad, what do folks generally mean when they say that? Because when I say good topology versus bad topology, really all I'm talking about is just the flow of your polygon components. I want to see your edges flowing nicely along the surface. I want to be able to look at the wireframe and really clearly see exactly what that shape is trying to define. But you don't necessarily have to have good topology to have quote-unquote good geometry. There's a difference. So, for good geometry, you want all quads and triangles. I also want to mention, all of these rules, you're probably going to end up breaking them at some point for one reason or another. Just know that going in, okay? So, but when I say good geometry, I generally mean everything should be quads and triangles. If it's something you're going to be using subdivision surfaces on, try to make it as many quads as you possibly can. Next, this is just another part of what I consider to be good good geometry most of the time, is nice topology. Doesn't have to. Like I said, these are all rules that you can break if you absolutely have to, but just know about them first. I'm just going to write this down. Normals. Pay attention to your surface normals. Is there anybody in the room right now who does not know what a normal is on a polygon surface? I'm looking for answers inside of BuzzNet. Okay, I'm not getting any responses. So everybody knows what a normal is. Well, I'll tell real quick. A normal is just the positive side of a polygon. You can picture it like a line moving out perpendicularly from a surface. Whenever you are making a model, all of your normals need to be facing outward. That's true in Blender and true in any game engine you want to export to, and true in a lot of different things. So hopefully everybody understands that. If you need help fixing your normals, just remember Control N. Control N, more often than not, will fix most of your normal problems because it just recalculates them and puts everything to the outside. Okay. Now let's see here. I like my geometry, and this is one of those kind of iffy situations. I like my geometry to generally be solid. Now, what does that actually mean? Well, what's the problem with a polygon inside of a computer? A polygon is infinitely thin. It has no thickness whatsoever. And so if you are building something that needs to be representative of a real-world object, you need to make sure that it is enclosed in such a way where there's never a polygonal edge just sticking out in space. For instance, let's say you're making a spaceship, and I'm going to make the most amazing spaceship in the world right now. You ready for this? Here's my spaceship. There's the cockpit, and there's the engines. Isn't it great? I don't know why it has... I don't know what it is. But imagine if these wings were just a single polygon thick. If you looked at them edge on, what would they look like? Well, they'd look kind of like this. You wouldn't even be able to see them. I'd like to say they'd look like a straight line, but they wouldn't even look like that because there's no thickness for that. So make sure that if you were going to model something like this, even if it needs to be thin, that you remember to give it some kind of thickness. Now, with that comes something else. Watch out for sharp edges. Now, what do I mean when I say sharp edges? Let me get rid of my beautiful spaceship. I know you're all probably missing it and hate to see it go. So, let's say I've got a cube that I just modeled out inside a Blender, or I just created, you know? By default, all of the edges inside of Blender are 100% perfectly razor sharp, and that never happens in the real world. In the real world, even if you have a reasonably sharply modeled out cube, very likely, if you were to get close enough to it, you would notice that the surface exhibited a little bit of rounding at some point, allowing you to get a little bit of a specular highlight right there on the edge. You never have perfectly sharp edges in the real world, for any reason. So that's definitely something to be aware of, and when you're modeling something, if you want your geometry to look nice, make sure you clean up those sharp edges so that they're no longer visible. I'm not saying you can't have any, but you do want to tuck them away if you happen to have any left over so that they're not visible to your typical viewer. Now, that being said, this is one of those steps I would definitely save for last. Because if you just go one by one through all of your hard edges and you use, say, the bevel tool or whatever operation you want to use to make those a little bit more rounded, that's great, but then if you need to go back in and do further modeling, you'll just find that you have a lot more geometry to work with than you really need.
Then you have to get your new things properly chamfered to match up and mixing the two together. Again, that's another situation where you ended up needing end guards. Just impossible.
Right, and what Gavin just said was that if trying to get everything chamfered or beveled to the same degree as what you had before can be a real pain, which is just another reason why this would be a step that you generally want to save for last. Okay, now, since there's a list of things to keep in mind for good geometry, here's a similar list of things to keep in mind that might mean you have bad geometry. And again, these are all guidelines. These all have moments when they're true and maybe other moments when they're not as true. If you still have n-gons, you probably have some bad geometry. I'm not saying that's true 100% of the time, but generally it's a good idea to make sure that those get re-topologized in some form or fashion, maybe with the knife tool or something, to put them back to quads and triangles. I love this word. Non-manifold geometry. You'll read about this. This will get mentioned in all kinds of papers and tutorials, and I think it even shows up in the Blender help file if you're scanning through that one. I did. Non-manifold geometry, the easiest way to look at it, or the easiest way to think about it, is geometry that is impossible. Basically, any piece of geometry that couldn't possibly live in the real world. So if you just have a single floating polygon, that's non-manifold geometry, because this guy, I mean, he's not even wafer thin. He's not even one atom thick. He is impossibly thin. So that's problematic. A Mobius strip? But a Mobius strip can happen in the real world. You're compounding things. Now here's another great example of another great example of non-manifold geometry. If I have a polygon surface that just has a single edge that's been extruded upward, this is non-manifold geometry. This couldn't possibly happen in the real world. And non-manifold geometry can lead to all kinds of problems later on when you get to rigging and skinning, when you get to texturing. It can just be a real pain.
Special mention for finding it inside the model.
I'm getting there. I'm getting there.
Sorry.
I know you didn't. Now, there are a couple of things I do want to mention about non-manifold geometry where maybe you shouldn't always be completely scared of it. There are instances where you can use non-manifold geometry to your advantage. For example, if you are creating hair for a game character. So here's your game character's head, and I don't know why their head looks like this, but this is what it looks like. In many cases, you're going to create their hair using strips of geometry. And it'll just be a little strip of polygons. This strip of polygons may be static, or it might have some rigging in it of some sort, or you might have already associated it with some sort of dynamic simulation so that it can bounce around and wave. But in many cases, this does not actually have any thickness. It's not like a great big French fry hanging off the side of their head. It's just an impossibly thin wafer. The trick, however, is that the negative side of it is generally always turned inward toward the side of the head so that you can't ever see that. Because in game engines, just in case you guys didn't know this, a polygon is visible from one side. That's an eyeball. A polygon is visible from one side, but not from the other. So if you're actually on the other side looking at it, you'll just look right through it like it's not even there. It's called backface culling, and to the best of my knowledge, all game engines do it. So this is one random edge case where you may find yourself utilizing what is known as non-manifold geometry, infinitely thin geometry. So like I said, all of these guidelines are here just so you know what they are. However, if you need to break the rules, at least know to break them when it makes sense. Also, you want to look for geometry that exists inside your object. It's really easy to miss this and overlook it, and then have all kinds of, not only additional calculations which are slowing down your scene, but all kinds of render glitches later on. Here's a for instance. If I have a character's arm, and here's their hand. Now, we know that the geometry that makes up their arm is really just a bunch of loops running this way, and then we have some edges running this way. However, sometimes if you're not careful, maybe based on how you extruded the shape, or maybe based on a whole bunch of other factors, inside the arm you might actually have a completely solid face. Because maybe at one point this was just a stump, and for whatever reason you extruded this, or you extruded it twice and didn't think about the other extrusion that you created, and you end up with faces inside your model. Watch out for those.
Particularly, say you've modelled the hand separately.
And then attached it later. Yeah, if you
and then forgot to delete the before the reverse.
Right, so what Gavin just said is if you are modeling things separately and then reattaching them later, you can really run into this internal geometry problem. And you definitely want to keep an eye on that. Even if you think it's not really that big of a problem, you'll often find that later on you'll be working, you'll be animating, and then you'll get to rendering, and for some weird reason that internal face just suddenly decides to jab out the side of the character and wave to the rendering engine and say, hey, here we go. And those are real problems. In magenta, yeah. Depending on what you're rendering out in, yeah. So definitely be aware that those will exist. And along with internal faces comes this. Doubled geometry. It's easy to make, especially in Blender. Actually, in Blender, yeah, in Blender, it may be easier to make than just about any other program I know of. It's funny, too, because Blender has a remove doubles tool, which is specifically made for solving this problem. And I always kind of laugh because usually after I show it, one or two people will be like, "Man, I wish Maya had a remove doubles feature," and it turns out it does. But every time they say that, I always kind of want to return and be like, "Yeah, but it's harder to do this in Maya."
Yeah, you know that version the one came out of Blender, and then somebody sent the thing and wrote the
Well,
doubles.
exactly. Now, the reason it's so easy inside of Blender is really just because of the way, especially extrusion works. I mean, that's the biggest reason. It doesn't mean that Blender's good, bad, better, worse, or forward, backward, or sideways. It just means that when you're working, it's easy to say, "Oh, extrude. Wait, I didn't mean to extrude," and just right-click and forget about it. And now, right now, at this moment, we can see that we have these face handles right here in the middle of our edges, and that's your dead giveaway. But, if you just immediately hit tab, you're like, why does this look so strange? Why does everything seem to be exploding? Yeah, exactly. And now he's got weird creases everywhere. And that's all because he has double geometry. So, it's just one of those things where it's easy to create, easy to lose track of, even easier if you do something, like a big extrusion somewhere and you don't think about it again till later, or maybe you've duplicated geometry at some point and you forgot to move it. There's all kinds of different ways you can create it. Just remember that at any point you can tap the space bar and start typing in remove doubles, and there it is. Make sure you use that, and use it often. Sometimes, often when I'm working inside of Blender, and I generally don't create double geometry, but I'm only human. So in a lot of cases, I will just grab all of my geometry, and just as an insurance policy, I'll go ahead and run a remove doubles on it, just to be safe. And it says remove 0 vertices. That's when I can pat myself on the back and know that I did a good job. Okay, so there is our big, long list of various things to keep in mind when modeling. Of particular importance is the concept of n-gons, the fact that we have them now. The great thing, for those of you who are still kind of, if we can't keep them, then why do we have them? One of the biggest reasons I can throw something out to you is the fact that the engine now supports them. Gives us the opportunity to use modeling tools which previously could not have possibly existed, such as the knife tool, which allows us to just slice in our own geometry wherever we want it. We weren't allowed to have that before because in using it, it's very likely that you could create an n-gon, something that has something other than 3 or 4 sides, and so we just didn't have that ability. And I'll tell you, once you get into truly modeling and having to tweak your models out and make adjustments, things like the knife tool, I don't know how you live without them, really. I can model just about anything you want almost just with the knife tool. Give me extrusions and a knife tool and I'll model anything you like.
Similarly, even modelling as long as Zach has, you still reach points with models where you don't know exactly what approach will work.
Right.
Or certainly which will work best. And this is, again, comes up particularly with smoothing, because if you've got triangles, that gives you poles and smoothing, and so you might work things through in different directions, and being able to backtrack with and avoid just using quads is hard.
Right. Well, what Gavin's basically saying there is just the ability to use n-gons to solve an approach which wasn't working properly, where you can just take all of the detail that was within a certain selection of polygons, say, you know what, this is not doing what I want it to do, nuke it, goodbye, dissolve it, let me cut it in a different way and see if this works better. Now you can do that, whereas beforehand, that was completely impossible and you weren't allowed. So it's definitely an improvement. Now that we've done a lot of this theoretical stuff, where we've just kind of talked about the basics of modeling, the next thing I want to do is go over some modeling tools. However, we are right about an hour into the class, so it's a good time for us to take about a 10-minute break. I need to get something to drink anyway. So what I'm going to do is go ahead and stop this video. We'll take a quick break, and we'll reconvene here in about 10 minutes.